and welcome to another set of ICP video notes. Today we'll be talking about acceleration. So first off, what is acceleration? Acceleration is a change in velocity. Now if you remember, velocity is speed and direction. So anytime there's a change in speed or a change in direction, or both, we would consider that an acceleration. So how do you recognize acceleration on a graph? Well, if you look at the position versus time graph here, you can see it changes in the slope. Anytime the slope changes in a position versus time graph, there's an acceleration. You could also look at a motion map. Anytime that your vectors on a motion map either get bigger or smaller, or they change directions, those would be considered accelerations. All right, a little bit of math that goes along with this. First, you need to know your variables. So we have Vf is the final velocity, Vi is the initial velocity, Tf is the final time, and Ti is the initial time. Then we have this triangle, that's the Greek letter delta. So delta V is Vf minus Vi, or we could call that the change in velocity. Delta T is Tf minus Ti, which is the change in time. And then A stands for acceleration. So if we put all that together, our equation is A equals Vf minus Vi divided by Tf minus Ti. Or we could say it's the change in velocity divided by the change in time. If you remember, our units for velocity is meters per second. So if we have velocity as meters per second on top, and times unit is second on bottom, then our unit is meters per second. And that should make sense because we're measuring the change in velocity over time. All right, so let's try some practice problems. The first problem says there's a truck that is sitting at a stoplight. It's at rest. So its initial speed is 0 meters per second. And then it says it speeds up to a speed of 75 meters per second. And this whole thing takes 15 seconds. So let's start with our equation. A equals Vf minus Vi divided by the time. Okay, so our Vf is 75 meters per second. Our Vi is 0 meters per second. And our change in time is 15 seconds. So then you get 75 meters per second divided by 15 seconds should get you about 5 meters per second per second. Notice that's positive 5, that means the truck is speeding up. When you have a negative acceleration, that means it's slowing down. Okay, our next problem is talking about a plane landing. So it says a plane's going 150 meters per second, and it makes it onto the runway, and it takes 25 seconds for it to come to a complete stop. So our initial velocity is 150 meters per second. The final velocity is 0 because it stopped, and it took 25 seconds for that whole thing to occur. So we start with our equation again. Vf minus Vi over delta T. So our Vf, our final velocity, is 0 meters per second. Our initial velocity is 150 meters per second. And our change in time was 25 seconds. It's very important that you put these in the right order, and remember that it's Vf minus Vi, because that'll give us our positive or negative acceleration. You can always check your answer when you get the answer to make sure that it is positive or negative based on the story problem. So this should give us an acceleration of, that would be negative 150 divided by 25 seconds, which would give us negative 6 meters per second per second. That should make sense. It's a negative acceleration, meaning the plane is slowing down. Okay, a little bit different this time. Now we're talking about a boat in the middle of its travel. So it's going 25 meters per second. That's the initial. And that is at time 25 seconds. So 25 seconds into its boat ride, I guess, then it's going 25 meters per second. It speeds up to a velocity of 80 meters per second. And it reaches 80 meters per second at time 35 seconds. So now we have to do the TF minus TI on bottom. And that'll give us our delta T. So our final velocity was 80. Our initial was 25. Our final time was 35 seconds. And our initial time was 25 seconds. So when you put all that together, you get A equals 80 minus 25 is 55 meters per second. Divided by 35 minus 25 is 10 seconds. That should give us an acceleration of 5.5 meters per second. Remember, that's positive because the boat is speeding up.